Okay, so I think I am audible. Any problem you can ask. Hello everyone, good evening. So we are going to start today the S parameter questions and some topics remaining S parameter. So first of all we will discuss S parameter, then at last we will discuss some questions. Okay. So today we are going to discuss question discussion. Today we have question discussion of S parameter, and yesterday we have done S parameter, and today we will do question discussion. So this top point is very important in S parameter. What is this point? The conversion of from ABCD to S parameter and from S parameter to ABCD. This conversion is very important. You have to remember this conversion. Okay. Then after we will go for the next point. That means we will go for the question discussion. Okay. This is our first question of S parameter. What is the first question? The question is two-port network is given and it is given S11, S12, S21, and this two-port network is second port is short circuited. You can see here it is written the second port is short circuited. It is not matched. If it is matched, then S11 will be equal to S11, but here it is written it is short circuited. Then they are asking the S11 for the resultant one. So we have to draw the diagram, and then after we will go through the points. So first of all, what we have to draw the block diagram. That means draw the diagram so that we can understand the points here. So first of all, we will draw the diagram. This is our S parameters block, and there is a input block. Yes sir, there is a output block. Ji sir. So okay. This is input port and this is output port. In input port we have V1 plus, and output we have V1 minus. This one we have V2 minus, and this one we have V2 plus. Yes sir. And there is a short circuit. That means ZL is equal to 0 at this point in second port. S parameter is given. What is S parameter? S11, S12, S21 and S22. It is given here. So what we will do? First of all, we will calculate the reflection coefficient here. We will calculate the reflection coefficient. So gamma L will be equal to ZL minus Z0, ZL plus Z0, and the ZL is 0. So we can say that the gamma L will be equal to minus 1. Gamma L will be equal to minus 1. So gamma L we have calculated, and gamma L has incident voltage V2 minus and reflected voltage V2 plus. so which is equal to minus 1. So we can say that V2 plus is equal to minus times of V2 minus. So this is the relation, first relation which we got. Then we have second relation also, that means V1 minus is equal to S11 V1 plus and S12 V2 plus. Then we have second relation, V2 minus is equal to S21 V1 plus and S22 V2 plus. So what we will do, we will put the value of V2 minus in terms of V2 plus in equation third. So this is equation 1, this is equation 2 and this is equation 3. So from first and 3 you will get the relationship between V2 plus and V1 plus. So from first and 3, so you will get V2 minus is equal to minus times of V2 plus is equal to S21 V1 plus and S22 V2 plus. Yes sir. So our V2 plus will be equal to minus times of S21 1 plus S22 V1 plus. This is the relation number 4. This is the equation number 4. Then using this equation first, second and fourth, I will put V2 plus here and I will get the relation between V1 minus upon V1 plus. So V1 minus is equal to S11 V1 plus S12 V2 plus. Yes sir. From equation 4 you will get V1 minus is equal to S11 V1 plus and S12 S21 minus times of S21 into V1 plus is equal to 1 plus S22. Then after what we will get? We will get the value of V1 minus. So S11 nu is equal to V1 minus upon V1 plus. So V1 minus upon V1 plus will be equal to S11 minus S12 S21 1 plus S22. So this is our new S11. This is our new S11. So new S11 we have calculated. So what we will do, we will watch which is new S11. So 1 plus S22, yes sir. 1 plus S22, yes sir. So 1 minus S22, 1 minus S22 and 1 plus S22. So this one is wrong, this one is wrong. So C and D option is wrong. Then after I will solve, what I will get? If I will solve S11 new, so S11 new is equal to S11 minus S12 plus S21 divided by 1 plus S22. So if you take denominator, so S11 plus S11 S22 minus S12 S21 1 plus S22, 1 plus S22. So our B option is correct. B option is correct. So B option is going to correct. So this question we have solved. This is a very good question they have asked in the GATE exam in 2013. Next question is this one. We have derived the formula for this one. Let us assume you didn't remember the formula, then after you have to calculate separately. If you remember the formula, then there is no problem. If you don't remember the formula, you have to calculate separately. Okay, so what is the point here? You should know the ABCD parameter. First of all, you have to calculate ABCD parameter, that means transmission line parameter. So transmission line parameter is 1, 0, 1 by Z and 1. Then you will put the value of this 1, 0, 1 by Z in scattering parameter matrix and then you will get the answer. So our scattering parameter matrix is this one. So what I have to put? I have put the value of ABCD. I have put the value of ABCD. So our T matrix is, for this one, is 1 0 1 by Z and 1. So I have to put this value, then the value will be, if I will put this value, the value will be A is 1, B is 0, C is Z0 by Z, and D is 1, and denominator will be same for all 4 cases. Denominator will be same for all 4 cases. Yes sir. So it will be same. Then we have on top 1 plus 0 minus Z0 by Z plus minus 1, and we have 1 minus 1 plus 0 minus Z0 by Z plus 1, and then after 2 AD minus BC. AD is 1, BC is 0, so 1 minus 0, and this one is 2. Then we will calculate the value. This one will be cancel out, so it will be minus Z0 divided by 2Z plus Z0. Yes sir. And this one is 2Z upon 2Z plus Z0. This one is same for this one, so this will be same, and for this one this will be same. So answer will be Z0. So we have calculated the value of what? S parameter for this network. S parameter for this network. So we have calculated S parameter. So our S parameter will be minus Z0, 2Z plus Z0, and second one is 2Z plus Z0, and third one is 2Z and 2Z divided by 2Z plus Z0, and minus Z0, 2Z plus Z0. Yes sir. Then Z0 is 50 ohm and Z is 50 ohm. So we have 50 ohm. So what we will put? We will put the value. We will get the value 50 divided by 150 and 100 divided by 150 and 100 divided by 150 and minus 50 divided by 150. So it will be how much? Minus 1 by 3, 2 by 3, minus 2 by 3, and minus 1 by 3. So answer will be reciprocal and symmetrical. We will see later. So this is answer. So answer will be minus 1 by 3 and 2 by 3, minus 1 by 2 by 3 and minus 1 by 3. So we will get the value of S parameter. Then after this is your question, this is your homework. You can do yourself. This is your T matrix, and you have to find out this value. The same data, same question they will ask in the GATE exam. Same data and same question they will ask in the GATE exam. So you have to give the answer. For that you have to do the calculation. So if you calculate it before, so you will get the answer very easily. If you not calculate, then it will take time in GATE exam. This is T matrix, and they will ask the question for T matrix. You have to give the answer. So this one is question number 2, and this one is question number 3. So they will ask the question from T matrix. Okay. So what we will do? I will help you, but you have to do by yourself also. This is self-assessment question, and you can share your question answer with my Telegram channel Sonu Sir PW. With my Telegram channel Sonu Sir PW, you can share your answer. I will check and I will give you the correct answer. That this one is correct or not. So solution, how we will do? So first of all, you have to find out ABCD matrix. ABCD matrix. This one is series. So this one is Z1, this one is Z2, this one is Z3. So first of all, you have to calculate 1 Z 0 1, and second one, this one is for this one 1 0 1 by Z1, add 1, and for third one is 1. So this one is series, so 1 Z, Z1, Z2, this one is Z2, Z1 is, it is Z1, yes sir, and 0 1, and this one is Z2, so we have Z2. So this one is the point here. So 1 Z1 0 1 for series ABCD, for shunt ABCD this one, for series ABCD this one. So you can do yourself, and then you will calculate the value of Z. Then you calculate the value of Z by multiplying. You will get the value of ABCD value. So if I will multiply, if I will do some aspect of this answer, so how will you do that? Then after you can multiply. So 1, and this one is Z1 by Z1. So 1 Z1 by Z2. Yes sir. Then after again we will multiply by this one. I will get Z1. Then again I will multiply by this row and this column. So I will get 1 by Z2. And again row and this column. So I will get 1. And second one is 1 Z1 and 0 and 1. Yes sir. Then after what you will do? You will calculate the value. Then again multiply. So if you multiply by this row and column, you will get 1 by 1 plus Z1 by Z2, and again row and multiply. Then after column, this row, this column and this row. So this row and this column you will get Z1. So it will be Z1 plus Z1 square divided by Z2, and this one is plus Z1 plus Z1. Then after you will multiply by this, so you will get 1 by Z2, and then after multiply by this, so you will get 1 by Z2 and 1 by Z1 Z2. So it will be Z1 by Z2 plus 1. So this is the relation you will get. So the relation is Z1 plus Z2 divided by Z2, and 2Z1 Z2 plus Z1 square divided by Z2. Yes sir. And then after 1 by Z2, and then after Z1 plus Z2 divided by Z2. So this is the point here. So Z1 and Z2, you know that. Just put the value, you will get the value. Just put the value, you will get. So Z1, Z2, you know that. Then after apply the formula. Which formula? Apply this formula. S parameter. When you get ABCD, just put the value of ABCD in this point, in this equation, and you will get the S parameter. So it is a very easy task. First of all, you have to calculate. So they will not ask whole ABCD. They will ask S11, they will ask S12, they will ask S21, they will ask S22. So you have to calculate ABCD first. So this one will take some time, 2 minutes, and for 1 minute for calculation of one parameter, S11, S21, S12 or S22. Okay. So this type of question may be asked in the GATE exam. Then after we have what parameter? Lossless and distortionless they will ask. They will ask lossless and distortionless, reciprocal, like that question they will ask. So in this question, what you will do? In this question, what you will do? they have given some S parameter. Yes sir. They are asking this is reciprocal or not, this is lossless or not. So you have to give the answer. This is question number 4. This is question number 4. So they are going to ask this is reciprocal or not, this is symmetrical or not. So for that you have to remember these all points. First point is 4. Which part? 4. I will go for next page, then I will solve this question. So first part will be what is reciprocal and symmetrical. First part you have to remember this. So for reciprocal, what is the condition? For reciprocal you have S11, S12 is equal to S21. That means forward gain is equal to reverse gain. Forward gain is equal to reverse gain. And for symmetrical it is S11 is equal to S22. This is the condition for symmetrical and this is the condition for reciprocal. So what is the condition then you get? Then you get that you have to match the magnitude. First of all you have to match the magnitude. S12 magnitude and S21 magnitude should be matching. And second one, the angle of S12 and S21 should be matching. So angle and magnitude both should be matched. Okay, then the S parameter should be matched. It's again this one, for this one also the angle and magnitude should be matched. Angle and magnitude should be matched. Okay, so from this we can see reciprocal, and for that, so this one magnitude and this magnitude. So here S11 magnitude and S22 magnitudes are not equal. S11 is equal to 0.2 at angle 0 degree, yes sir, and S22 is equal to 0.1 at angle 90 degree, yes sir. So we can see here S11 magnitude is equal to 0.2, S22 magnitude is equal to how much? It is 0.1, and the angle of S11 and S22 is equal to 0 degree and the angle of S22 is equal to 90 degree. So you can see here S11 magnitude and S22 magnitude is not matching. So you can say that S11 is not equal to S22. That is, it is not symmetrical. It is asymmetrical network, asymmetrical network, yeah, unsymmetrical network. Okay, it is not symmetrical. Okay, then we have to match S12. S12 is how much? So S12 magnitude is equal to S21 magnitude. Yes sir, S12 magnitude is 0.9. So it is 0.9, and angle of S21 and S12 and S21 angle is same. S21 angle is same, 90 degree. So we can say that S12 is equal to S21. So it is reciprocal. So it is reciprocal. So reciprocal, correct. Not reciprocal, wrong. Reciprocal, correct. Not reciprocal, wrong. So we have B and D option are wrong. Then we have to check lossless and not lossless. So in previous class I have taught you lossless and not lossless. I will just remind you. So for that, what you will do for lossless and not lossless? So for lossless and not lossless, you have to remember these odd points. Yes sir. What are the points? First point is, for first network you have to, for first port you have to realize, for second port you have to realize. Though for port 1 and this is port 2, this is port 2. Okay, so for lossless condition, what it will be? For lossless condition, mod S11 square, and always try to remember here not S12, it will be S21. S21 square is equal to 1, and mod S22 square, it is not S21, it is S12 square is equal to 1. Okay, then we have second case. Second case is for lossy. What will be the answer? So for lossy, the answer will be, lossy a mod S11 square plus S21 square is less than 1, and mod S22 square and S12 square is less than 1 for lossy. And for amplifier, what is mod S11 square, S21 square should be greater than 1, and mod S22 square plus S12 square should be greater than 1. Yes, sir. So this is the point here you should remember. This is the point here you should remember. Okay, you should remember. You should remember. So this is our lossy. First one is lossless, second one is lossy. So first one is lossless, second one is lossy, and third one is amplifier. For lossless, there is another condition also. For lossless, there is another condition also. So what is the condition for lossless? For lossless, there is another condition also. You have to make short notes of transmission line. Then you will remember all these points, because there is so many points in the transmission line. Yes, sir. Like other chapters also. So you have to make short notes. So what are the next point? S transpose, S conjugate should be equal to identity matrix. So it is very beautiful question. S transpose, S conjugate should be equal to identity matrix. So you don't have to remember this one. If there is 3 port, this equation is invalid. If there is 4 port, this equation is going to invalid. So this is only for 2 port only, and this equation is for any port, 2 port, 3 port, 4 port, any port. You can apply this formula for lossless. So it is very important. So it is very important. So you have to remember this formula, and then after you can solve the lossless condition for any port transmission line. Okay. So S transpose is equal to, S transpose is S11. In case of S12, there is S21 and S12 and S22, and there is S conjugate is S11 conjugate, S21 conjugate. So I am just applying conjugate only. Then after S12 conjugate, then after S22 conjugate. Yes, sir. And then I will multiply, and then I will get the answer 1 0 0 1. This is identity matrix. Yes, sir. So what you will do, first of all, you will multiply and you will get the answer. First, this first row and first column, S11 and S11 conjugate mod S11 square, S21 and S21 conjugate, it will be mod S22 square. So I have written this one wrong. I have applied conjugates only. Okay, is equal to 1. First row, first column, this one is 1. First row, second column. So first row, second column, you will get 0. Then second row, first column, you will get 0. Then second row, second column, you will get 1. So second one is second row, second column. So mod S12 square plus S22 square is equal to 1. This is the point. This is known as unitary property. So you can make a point here, It is known as unitary property for lossless transmission, for lossless device. Then after, second one is zero property. So first row, second column. So S11, S12 conjugate, and second one S21, S22 conjugate, S21, S22 conjugate is equal to 0. So this is known as zero property. This third equation is known as zero property. Then again we have first row, first column, second row, first column. It will be S12, S11 conjugate, and second S22 and S21 conjugate. S21 conjugate. It is equal to 0. So this is known as zero property for lossless transmission. This is known as zero property for lossless transmission. So you can check two property for lossless device. First one is for zero property and unitary property. So from this lossless condition, you will try to find out, you will get 4 points. That means you will get 4 unknowns. One unknown here, one unknown here, 2 unknowns, one unknown here, 3 unknowns, one unknown here, 4 unknowns. So from lossless condition, you will get 4 unknowns only. So it is very beautiful question if they will design for 4 unknowns and they have written lossless. So from lossless, you will get 4 unknowns. Okay. Then we will go for the question. It is reciprocal, and for lossless I have to check. So what we will do, S11 and second one is S12. So what you will do, S11 and S12 square, it should be equal to 1. So this square plus this square should be 1. This square is 0.04. This square is 0.81. So what you will do, you will see S11 square 4 port 1 and S12 square 4 port 1. It will be equal to 0. It will be equal to 1. So it will be 0.04 and plus 0.81 plus 0.81. So it will be 0.85, which is less than 1. So port 1 is lossy. Port 1 is lossy. It is lossy. It is not lossless. Then we have S21, S12 square, S12 square plus S22 square. S12 is how much? It is 0.9. So 0.9 square, and it is 0.1. So 0.1 square. It is 0.82. It is less than. So port 2 is lossy. Port 2 is lossy. 2 is lossy. Port 1 is lossy. Port 2 is lossy. So it is lossy. It is not lossless. It is lossy. It is not lossless. Okay. So it is reciprocal but not lossless. So lossless, no. Not lossless, yes. So our answer will be C. So if I will go through the only solving the example, then it will be very easy. S12, S21 you can check very easily. 30-second question, and for lossless you will check only a square. You will get the answer. But the concept behind this is this one. So you have to understand this concept. Then you will solve the new question related to this concept. Okay. So I am here to teach you how to solve new question related to this concept. Okay. Then we have one more question. What question, sir? Then we have one more question. That means one more point. That means return loss. Yes, sir. That means return loss we have to find out. Yes, sir. So return loss we have to find out. Then after we have to find out VSWR. Yes, sir. Then after you have to find out gain. Yes, sir. So these all things you are going to find out, and we are going to find out. So first one is return loss. First one is a return loss, some parameters. You will write some parameters. So these are the parameters from which they will ask the questions. So you will first question is, what is return loss? What is return loss? So return loss is equal to, it is loss, so I will put minus sign here, and the S parameter is ratio of what? It is ratio of voltage, so I will write for voltage what will it will be. So for voltage it will be 20 log. For voltage it will be 20 log. So minus for loss 20 log for voltage ratio, and in dB it will be S11 magnitude. So this one is return loss at port 1. I will not write like this, it will be hectic. So return loss for port 1. Return loss for port 1, some important parameter. Return loss for port 1, what it will be? It will be minus 20 log 10, yes sir, magnitude of S11, or it will be minus 20 log 10, it will be magnitude of reflection coefficient, yes sir. For return loss port 2, at port 2 the return loss will be, so they may ask return loss at port 2 also. So what is the value of return loss for port 2? For port 2 it will be S22, it will be S22. So for port 2 it will be S22. Okay. Then after VSWR at port 1 is, VSWR at port 1 is, at port 1 VSWR it is equal to 1 plus mod S11, 1 plus mod S11, 1 minus mod S11. Okay. Then fourth one is VSWR at port 2. At port 2, what it will be? It will be 1 plus mod S22 and 1 minus mod S22. So this is the VSWR at port 2. Then forward gain, since it is gain, so I will take plus. Since it is loss, I will take minus. Since it is gain, I will take plus. At 20 is for voltage ratio, so S parameter is voltage ratio, so I will take 20. So this is our forward gain. This is our forward gain. Okay. Then we have 6 point reverse gain. What is reverse gain? So reverse gain is equal to 20 log 10 S12 magnitude, S12 magnitude. So this is 20 log 10. Then after, this is the all points, forward gain, reverse gain, everything. Then after we have to calculate insertion loss. Then after we have to calculate insertion loss at port 1. What is insertion loss? I will teach you from one example. So insertion loss, let us assume this is the insertion loss formula. So insertion loss is, if I am putting some if I am giving some input power 5 watt, yes sir, I am getting 2 watt, so there is a loss of 1 watt. That loss is known as insertion loss. If I am giving some power from this port to this port, so there is 5 watt, 2 watt is reflected by, no problem. 2 watt is transmitted, no problem. But there is one loss which is 1 watt, which is known as insertion loss. Like that here also, I am giving power 5 watt. Yes sir, I am giving input power 5 watt. 1 watt is reflected, 3 watt is transmitted, but 1 watt is loss. That one is what is known as insertion loss. Insertion loss is calculated in dB. It is very important because they will ask this question. Sometimes I am waiting for that question, but they will ask this question. So this is insertion loss. Transmission coefficient S11 is related to S21. So S11 is related to S21. So mod S21 square 1 minus S11 square. And this is insertion loss formula for port 2. So insertion loss formula for port 1 is this one. Insertion loss formula for port 2 is this one. So you have to remember, for port 1 it will be S21 square upon 1 minus S11 square, and for port 2 this one is the insertion loss formula. So they will ask this question, insertion loss formula, you will give the answer. Okay. Second one is insertion loss formula minus 20 dB. Minus is why? Because there is a loss, so it will be written in terms of minus. Since it is square, so it will be 10 log. Sorry, it will be 10 log. So since it is a square, it is related with power, so it will be 10 log. So square, so 10 log. Not related with power, so 10 log, and this one is also 10 log. Then after S21 square 1 minus S11 square, S12 square 1 minus S22 square, you will get the answer. If I will say 1 minus S11 square is greater than 0, is less than 0, let's see for amplifier, let's see insertion loss for attenuator, and let's see insertion loss for lossless. So first of all, I will see for lossless. For lossless, insertion loss will be what? So for lossless, 1 plus 1 for lossless, S11 square plus S21 square is equal to 1, is equal to 1. So we can say that it will be equal to 1. For lossless, S11 square plus S21 square is equal to 1. Yes sir. So we can say that S21 square is equal to 1 minus S11 square, 1 minus S11 square. So insertion loss will be equal to, so insertion loss at port 1 will be equal to minus 20 log, minus 20 log, sorry 10 log 10, 10 log 10 S21 square upon 1 minus S11 square. Both are equal, so ratio will be, both are equal, so ratio will be 1, and log 1 is how much? Log 1 is 0, so it will be 0. Second case is our, what is second case? For lossy. For lossless at port 2, we will see lossless at port 2. What is the condition for lossless at port 2? So at port 2 we will see, this is at port 1, then at port 2 1 is equal to S22 square plus S12 square. So S12 square will be equal to, it will be 1 minus S22 square. So the ratio will be equal to 1. So S12 square upon 1 minus S22 square it is equal to 1. And insertion loss at port 2 is equal to, so insertion loss at port 2 is equal to 0, because the ratio is 1, so you will get insertion loss at port 2 is equal to 0. Yes sir. Then we have next point, that means second case for lossy. For lossy, what will happen for lossy? So for lossy, it will be first point, first port, you will get S11 square plus S21 square is equal to less than 1, is less than 1. So what you will get? S21 square is less than 1 minus S11 square. Yes sir. So you can say S21 square upon 1 minus S11 square, it is less than 1. It is less than 1. So insertion loss at port 1, it will be equal to minus 10 log 10 and S21 square upon 1 minus S11 square, it will be equal to greater than 0, because less than 1 log will be negative and negative it will be positive. So for port 1 it is positive. Similarly for port 2 you can get. So what is port 2? Port 2 you will get similarly S22 square and plus S12 square is equal less than 1. That means S12 square 1 minus S22 square is less than 1. That means insertion loss at port 2 is greater than 0. Positive value. Similarly you can solve for amplifier also. In case of amplifier it is greater than 1, so it will be insertion loss will be negative, and in case of amplifier it is greater than 1, so insertion loss will be negative. So there is no loss, so insertion loss should be negative. Yes sir. Then after insertion loss you have solved the return loss. Then I will go through the one question. What is the question behind this? There is a return loss of a device is found to be 20 dB. So return loss is given here. What is given here? Return loss is given here. So return loss is equal to return loss in dB is equal to, it will be minus 20 log 10 magnitude of reflection coefficient. It is equal to 20 dB. So magnitude of reflection coefficient will be equal to 10 to the power minus 1. 20 divide, so it will be 10 to the power minus 1. So it will be 0.1. Then they have asked VSWR. VSWR is equal to 1 plus mod gamma and 1 minus mod gamma. So it will be equal to 1 plus 0.1, 1 minus 0.1. So it will be 1.1 divided by 0.9. So how much it will be? It will be 1.22. So VSWR will be equal to 1.22. So our answer will be A. It is a simple question. This is question number 5. Next, question number 6. We have question number 6. So this is last question. It is a very beautiful question. They have asked in GATE 2023. In GATE 2023, they have asked this question. In GATE 2023. So this is question number 6. S parameter. Yes, sir. So what is the question? Here S parameter is given, S11, S12, S21, S22 of two port network is given. Then what is happening? It is shifting some length L1 they are adding, and here some length L2 they are adding. So they are saying S parameter for this network is S and S parameter for this network is S dash. So they are saying the S parameter for this network is S. So for this network it is S. Yes sir. And for this network it will be S dash. So this is the point here. So what they are saying, for this network it is S and for this network it is S dash. So due to addition of length, what will happen? They are asking, and they have given four option. You have to give option according to that. So what we will do, I will go for the like a I will go for like a theoretical concept. Like a theoretical concept, I will derive this, so that if they will ask again, you will give the answer very carefully. So that they will ask again, you will give the answer very carefully. Okay. Okay. So first of all, what is S11? So here V1 plus, and the reflected one will be V1 minus. Then we have V1 by V2 minus, and we have V2 plus. Yes sir. You have to know this one, V2 plus, and the S parameter will be something like that: S11, S12, S21 and S22. They are adding some length. That means here it is V1 plus, here it is V1 plus, and here it is V1 plus dash. Here it is V1 plus dash. Here it is V1 minus dash, and here it is V1 minus. Yes sir. Then here it is V1 plus dash. Here it is V2 minus dash, V2 minus, and here it is V2 minus dash. Then after, here it is V2 plus. Yes sir. And here it is V2 plus dash. Yes sir. So what we will do, first of all, we will going to calculate the value of S parameter. So the new S parameter is defined according to which parameter? This with reference to this one. So this one will give us, which part? This one will give us S dash. This one will give us S dash. So I have to find out S dash. Okay, I have to find out S dash. For that, what we will do? If you want to find out S dash, you have to calculate what? You have to give the relationship between V1 plus and V1 plus dash, V1 minus and V1 minus dash, and V2 minus and V2 minus dash, V2 plus and V2 plus dash. Then you will get the answer. So what you have to do? You have to just give the relationship between these 2 points. Give the relations between these two. If you get the relation, then you will solve easily. If you are not getting the relation, then you are not going to solve easily. So the arrow direction is very, very important. This wave will move here, this wave will move here, and this wave will move here. So I will ask what will happen. This one will give V1 plus. So V1 plus is output, V1 plus dash is input. Yes sir. V1 plus dash will give V1 plus. How much distance it is traveling? L1 distance. So it is J beta L1. Yes sir. So I can write down V1 plus dash e to the power minus J theta 1. Yes sir. Okay, no problem with that. V2 plus dash is equal to, so V2 plus will be getting from V2 plus dash. Yes sir. So it is traveling the distance L2. So e to the power minus J beta L2. So you are getting V2 plus dash e to the power minus J theta 1 theta 2. Yes sir. E to the power minus J theta 2. Then you are getting from V1 minus, you are getting V1 minus dash. So V1 minus dash is equal to V1 minus e to the power minus J theta 1, and V2 minus dash is equal to V2 minus and getting e to the power minus J theta 1. So V2 minus and e to the power minus J theta 2, simply in terms of length, and it will be J theta 2. Yes sir. So what we are going to get? You are going to get the answer. So how you will get the answer? Then you will write the equation. What is the equation? The equation is V1 minus is equal to S11, V1 plus S12, V2 plus and V2 minus. So in place of V1 minus, you will write down V1 minus dash. So V1 minus dash will be equal to V1 minus into something. So V1 minus will be equal to V1 minus dash e to the power plus j theta 1, and V2 minus will be equal to V2 minus dash e to the power j theta 2. Yes sir. So I'll put it here. I'll put the value. What you will get? So V1 minus is equal to V1 minus dash e to the power j theta 1, and S11 V1 plus dash e to the power minus j theta 1. Yes sir. V1 plus dash e to the power minus j theta 1, and S12 V2 plus dash e to the power j theta 2. E to the power j theta 2, it is dash. Yes sir. And V2 plus dash, it will be j theta 2. So I will write it separately. You will see the dash. Yes sir. Then we have second one is S12 and V2 plus dash e to the power minus j theta 2. So I will do, I will put it here in j theta 1. So V1 minus dash, it will be S11 V1 plus dash and e to the power minus j theta 1 2 theta 1, e to the power minus j 2 theta 1, and second one is S12 V2 plus dash and e to the power minus j theta 1 plus theta 2. Yes sir. Similarly you will get the answer. So you will write it down. I am turning off the page. So V1 minus dash is equal to S11 e to the power minus j theta 1 plus theta 2 and V1 plus dash and S12 e to the power minus j theta 1 plus theta 2, it will be V2 plus dash, it is 2 theta 1. Yes sir. So you are getting like this. Yes sir. Yes. Again similarly you will get what? V2 minus dash is equal to S21 e to the power minus j theta 1 plus theta 2 and V1 dash V1 1 plus dash and S22 and e to the power minus j 2 theta 2 V2 plus dash. Similarly you can get. So you can get the value from similarly that how you are derived this first equation, you will get this second equation also by similar derivation. So what you will get? You will get S parameter. So our S parameter will be this one. Our new S parameter will be this one, and this one. So our new S parameter will be S dash will be S11 e to the power minus j 2 theta 1 and S12 e to the power minus j theta 1 plus theta 2 and S21 e to the power minus j 2 theta 2 and S22 e to the power minus j theta 1 plus theta 2 and it is 2 theta 2. So you are getting the value like this. So answer will be A. Why it is not correct? Because it is plus, and this one is also plus, so it is wrong. This one is 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 also plus, so it is wrong. So our answer will be A option only. It is GATE 2023 question. Then what we will do? Then our S parameter is over. S parameter is over. Okay. So our question discussion for S parameter is over. Question discussion for S parameter is over. Okay. So we will meet it again. Our Unity app you can download. It is a very good app, and then after you can download you can go through the Telegram link Sonu Sir PW. You can go through the Telegram link Sonu Sir PW. You can ask any doubt or any question or any answer you want to share. You can ask through this Telegram link. Thank you. We will meet it again. Thank you.